Myself Mahesh, Department of CSCAML, St. Martin's Engineering College. Today I am going to discussing about Q. Q is a linear data structure. First of all, we have to know that about. First of all, we have to know about the what Q. What is a Q? Q is a what? Q is a what? A linear data structure. So that first of all, we have to know about what? A data structure. What is a data structure? Data structure is a way to store and organize the what data that it can be used in what efficiently. Here we can see that types of data structures. How many types of data structures are there? Two types of data structures: primitive data structures and non-primitive data structures. Here again, in the non-primitive data structures, it has been classified into again two types: linear data structures and non-linear data structures. Let us see here. Primitive data structure. Here we can see that primitive data structures that are what? Primitive data types. What are primitive data types? Primitive data types are nothing but an int, char, float, double, and what? Pointers. Those data types we are going to calling as what? Primitive data structures. Next, non-primitive data structures. Non-primitive data structures again it has been classified into two types. What are that one? Linear data structures and what? Non-linear data structures. Let us see here linear data structures. The linear data structures are purely we are going to calling as what? Sequential manner. First here we can see that the arrangement of the data in what? Sequential manner is known as an linear data structures. The data structures used for the purpose of what? Arrays, linked list, stacks and queues. Here we can see that in this data structure, one element has been going to connecting with another element. One element has been going to connecting with another element. Next, here we can see that non-linear data structures. Non-linear data structures are what? Nothing. It is not not ever going to arranging in the what? Order. First, here we can see non-linear data structures are stored. Non-linear data structures are the data structures where data elements are not arranged in sequential order. In the linear data structure, they are arranged in sequential order. Okay. Next, here we can see that the insertion and removal of data are not feasible in the linear manner. There exists a hierarchical relationship between the what? Individual and data items. Let we can see the diagrammatical representation here. This is what our data structure diagrammatical representation. Data structures has been classified into two types: primitive data structures, non-primitive data structures. Next, again the primitive data structures has been classified: integer, float, character, and boolean. Non-primitive data structures, linear data structures, and non-linear data structures. Purely we are going to discussing about what? Linear data structures. Here we can see linear data structures are again classified into four types. First one will be arrays, stack, queue, linked list. Non-linear data structures are tree, graph, hash table. Let us see here the one example for that one. First, first arrays. In the array it will be what? One pixel size. Here we can see that if I want to store the elements in the array, my array size will be what? Some 5. So that what happened? I am going to drawing as what? The index number will start from 0, 1, 2, 3, 4. This is the what? Fixed size of the array. Next, here we can see that array is also linear data structures. In the array also elements are stored in sequential manner. To overcome this problem, they have introduced what? Linked list. Linked list. In the linked list, it is also linear data structure. It is also purely linear data structure. In this linked list, again it has been classified into three types: single linked list, double linked list, and circular linked list. In the linked list, what happened? For this part, we are going to calling as what? Node. Node is nothing but it containing the what? Elements. Here we can see this one we are going to calling as what? Data part. This one we are going to calling as data part. This one we are going to calling as what? Linked part. Linked part. If suppose here there will be what? My data. That is what I want to give. Here I want to give it as some data will be what? 40. Here will be what? Some x I am going to give. This is what my reference variable to the what? Next node. Next node. Here the data will be what? 50. Here will be what? Y. Next. Here I am going to give you as what? 60. This will be what? Z. Like this, at last, it has been going to containing 70 null. If there is no reference, we are going to marking as null. Here we can see that 40, 50, 60 and 70. This one we are going to calling as data part, this one we are going to calling as what? Linked part. So that what happened, X has been going to linking with what? 50 and Y, 60 and Z. Next to 70 and null. The last node it has been going to contain null in what? Every linked list. Here we can see that this one we are going to calling as single linked list. In the double linked list, it is going to containing three parts. First part will be previous reference part. Second, here will be data part. Here will be referencing to the next node. Let us see here. Let us see about what? Double linked list. First part, second part, third part. First part will be referencing to the previous node. First part, getting the reference from the what? Previous part. This will be some X. Next will be data part. Data part will be some 50 or 60. Next will be what? Z. Z has been going to reference into the next part. That will be what? 1, 2. Z. X, 50, Z. Z is referencing to some M. And again here will be what? Some data part, some 40. Next here some N. In this also, the last node has been going to contain null. The last node it is also going to contain null. Some 60, some 8. This is double linked list. Next, circular linked list. Circular linked list is same as linked list. But what happened? Here there is no null. This one again has been going to connecting with the what? First node. So that is the thing. Linked list has been classified into three types. First one will be single linked list. Second one double linked list. Third one circular linked list. Both these are arrays and linked list comes under purely linear data structures. The data it has been going to arrange in what? Sequential order. Okay. Next, stack. Stack is nothing but it comes under what? Cylindrical data structures. Best example we can take water bottle. If I am going to fetching the water from the tap, okay, first when I am going to pour in the water, the bottle will be what? It has been going to fill. After that, it has been going to come up. Same as here also, it has been going to fill from the down. It has been again here. At last, it has been going to fill up to what? Top. Here the stack. For adding the elements, we are going to calling as what? Push. For deleting the elements, we are going to calling as what? Pop. Push and pop. In the arrays, adding the elements. In the linked list also, we are going to calling as what? Adding the elements. Okay. Next, here also pop, deletion of the elements. In the push, adding the elements. But here we are going to call it as what? Addition, adding the elements and deletion the elements. Deletion of elements. In the same way, here also the adding the elements and what? Deletion of the elements. Next, data structures. Hierarchy of data structures. Primitive data structures, non-primitive data structures. Arrays, stack, queue, linked list. Non-linear data structures, tree, graph, hash table. Now purely we are going to discussing about queue. First, queue. I am going to discussing about queue. A queue can be defined as what? Order list which enables insert operation and delete operation. The insert operations we are going to calling as what? Array. and delete operation we are going to calling as what? Friend. Here we can see that Q is what? First in, first out. Q is first in, first out list. Next one. For example, we are going to see that waiting a line for a railway ticket on a queue. Next, this is what? NQ and DQ. For adding the elements in the queue, we are going to calling as NQ. For deleting the elements, we are going to calling as DQ. Entering the elements from rear. Deleting the elements from front. Deleting the elements from right. Best example here we can see about Q. Q is a data structure similar to the Q in the real world. A Q data structure, it comes from it. First we are going to focusing on what? FIFO, first in, first out. While we are going to coming to the stack, stack is nothing but it is last in, first out. Whatever we are going to inserting in the last, that will be coming first. But while coming to the queue, it will be what? First in, first out. Queue can be defined as what? List or collections in which insertion done from one end known as rear end, that will be tail, and whereas deletion done from the another end, it is known as front end. It is known as front end. The real world example for the queue is ticket queue outside a cinema hall, where the person enters into the queue, get first ticket, where the last person enters into the last, he has been going to getting last ticket. Similarly approach we are going to follow here. This is what first, second, third, fourth. NQ, DQ deleting the from the first, and rear, front. Here we can see the example for this one. Ticket. He was issuing the ticket for the person who was standing in the what ticket counter. He has been going to issue the ticket. The first person has been going to get the first ticket. The second person has been going to get the second ticket. The third person has been going to get the third ticket. Fourth person has been going to get the fourth ticket. Fifth person has been going to get what? Fifth ticket. Here, person who entered the first receive the movie ticket first. The person those who enter the last, he has been going to get the what? Last ticket. Next, types of queue. The queue has been classified into purely four types. First one, simple or linear queue. Next, circular queue. Next, priority queue. Next, double-ended queue. First, we will see the simple queue. Simple queue or linear queue. It is same as like queue. It is same as like a queue. Here we can see linear queue. The insertion will be done from one end. Deletion will be done from one end. It is also showing as like queue. Next, the header. Next, it follows FIFO rule. FIFO stands for first in, first out principle. FIFO stands for first in, first out principle. The diagrammatical representation of linear queue. DQ, same as it is also same as like what? Same as like a queue. Next, circular queue. It is what? Very important. Circular queue. Here we can see that what happened. The last element, whatever the last element of first element, again it has been going to come into what? Connecting with the first element. Let us see. In a circular queue, the nodes are presented as circular. It is similar to the linear queue, except the what? Last node. The last node again it has been going to connect with the first node. In the similar linear queue, except the last element of the queue, it is connected to the first element. It is also known as a ring buffer. It is also known as ring buffer. All the ends are connected to the another end. The representation of the circular here we can see the diagrammatical representation. This is what I am going to iterate. Whenever the last element is there, again it has been going to connect it with the what? First element. Here we can see the one more diagrammatical representation. Here I am inserting first 1, second will be 2. Next, when I am going to say as ring buffer, here we can see that first 0, 1, 2, 3 and 4. 4 is what? 4 is again I am going to enter the second element. First element I have inserted 1. Second element I have inserted 2. If I am going to inserting the third element, the 1 will be placing here. The 2 will be placing here. Again the 3 will be placing here. If suppose again I am going to inserting 4. 1 will be placing here. 2 will be placing here. 3 will be placing here. 4 will be placing here. If suppose again I want to insert one more element 5. Then 1, 2, 3, 4 and 5. Again I want to insert sixth element. Then what happens, sir? Then automatically wherever the 1 is there, it will be deleted from here. Then it will be coming to this side, that will be what? -1. 1, 2, 3, 4, 5. When I am going to inserting the sixth element, that will be placing as what? 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Here also in the same ring buffer also. In the ring buffer also it has been going to come like that. If suppose here we can see that the 1 will be placing it here, 2 will be placing here. If again I am going to adding the elements, again I am going to adding the elements 1, 2. If suppose I am adding the elements, the next element will be placing here, the next element, and after that it automatically deletes. Automatically it will be deleted. That comes under -1. Here we can see that applications of circular cube. One best example for the circular cube, we can see that daily way. What happened in the traffic signals? There will be traffic lights. The lights will be orange, red, and green. Automatically, what happened? The person is not there. Automatically, it has been some software has been installed and they are inserted and they are going for that. First, what happened when automatically red blinks? The people those who are there on that line, they are going to be stopped. And if automatically the orange will be there, at the time the what the people will they are going to start their engine, they are ready to move. If green light is there, automatically the flow people has been going for that. First here we can see that applications of circular cube. First we are going for what? Memory management. In the circular cube provides purely memory management. As already seen the same as like what? Linear cube. If memory is not managed very efficiently, but in the case of circular cube, the memory is managed efficiently by placing the elements in the location which is unused. Next, CPU schedule. CPU schedule. The operating systems also use a circular cube to insert the process of execute them. This is next example. Traffic system. Here we can see that it is what main important. In a computer controls traffic system, traffic lights is one of the best example for circular cube. First, each light of the traffic light gets on one by one after every interval of time. Like red light gets on, okay, for 1 minute the yellow lights were on. The 1 minute again the green light will be on. Then afterwards green light, the red lights, it continuously does what? Getting going on. Okay. Next, here we can see that. Priority. Here we can see first priority. Based on the what? The priority has been classified into two types: ascending and descending. First, here we can see that it is a special type of a cube which elements are arranged based on the priority. First, in the special type of the cube data structure, where elements are priority associated. Suppose some elements occur with the same priority, then they will be what? Arranged according to the FIFO principle. First in, first out principle. The representation of the priority queue is what shown in the below. Here we can see that elements with the what? Highest priority. This is what my descending order. 80, 30, 20, 10, 5. If suppose there will be one more element, again 30 is there. Again 30. So that where should I have to insert, sir? First we have to see that what is the largest number? 80. 80 will be placing it first. Second 30. Again 20. Again after 30 is there. Then what should I have to do? Again I have to place here. So that here what happened? 80, 30, 30, 20, 10, 5. This is about what? Decreasing the priority order. Here also there will be an N cube. Here also deleting the elements from the D cube. Next, there are two ways to priority queues that are discussed as follows. First will be what? Ascending order. Second will be descending order. In the ascending order, I have taken the elements 7, 5, and 3 in the what? Same order. Then what happened in the ascending order? The elements will be placed at 3, 5, 7. 3, 5, second. Next, in the descending order, same elements I have taken 7, 3, 5. Then what happened? 7, 5, and 3. Next, here we can see that application of priority queue. It is used to what? Algorithms. It is used for Prism's algorithm. It is used for data compression techniques. It is used in the heap sort. It is used for what? Operating system, priority schedulings, and load balancing, interrupted handling. Next, it is what? Very important. DQ. In the first, we said, adding the elements in the queue, we are going to calling as what? NQ. Deleting the elements, we are going to calling as DQ. So that, what happened here? DQ stands for double-ended queue. In the interview may ask the question, what is DQ? At that time, we have to say about this DQ. We should not say deleting the elements from the queue. It is wrong. So that we have to say this one. DQ. DQ is nothing but a double-ended Q. Insertion and what? Deletions can be performed on what? Both the ends. From the front side and from the what? Rear side. From the front side as well as from the what? Rear side. So that what happened here? It means that we can insert and delete elements from what? Both front and rear of the Q. DQ can be used as palindrome checker. Palindrome checker is nothing but if I am going to write it as a madam, M-A-D-A. When I am going to come in from the reverse order also madam, and when I am going to come in from the front part also madam, and rear part also it has been going to come as madam. So that DQ can be used for palindrome checker. Means that if we read the string from the both the ends, the string would be same. The string would be same. Next, DQ can be used for both stack and queue. It allows the insertion and deletion from both the ends. Next, DQ can be considering as a stack because the stack follows the LIFO principle, last in first out principle, in which insertion and deletion both can be performed at one end in the stack. And in the DQ, it is possible to perform both insertion and deletion from one end, and DQ does not follow FIFO principle. Why it has been going to why it does not follow the what? FIFO principle. First in, first out. Next, the representation of the DQ here we can see that first I am going to insert it from the rear part. I am going to insert it from the both the parts, front part and rear part. I am going to deleting the elements from both the parts. That is nothing but a double-ended queue. Here also some restricted are there. Okay. In the double-ended queue, it has been classified into two types: input restricted and output restricted. Let us see the first one. Here we can see that input restricted. As the name implies that input restricted, queue insertion operation can be performed on only one end, while deletion can be performed on both ends. Sir, can I perform both sides? No. Deletion can be performed. Here we can see that input restricted. In the input restricted, we have to insert any one side. It may be from the front side or it may be from the rear side. But deletion can be performed anywhere. Deletion can be performed anywhere. Sir, I can add from here. Yes. I am inserting the elements from the front part. I am deleting the elements from the both the parts, front part as well as rear part. Front part as well as rear part. Next, output restricted. Here we can see that as the name implies in the output restricted queue, deletion operations can be performed at only one end, while inserting can be performed on both ends. Opposite, input restricted and output restricted. In the input restricted, what happened? I am going to inserting from one side. Deletion can be performed on both sides. While I am coming to what? Output restriction, I am going to inserting the elements from both the sides. Deletions can be performed on what? Only one side. Deletion can be performed on what? Only one side. Next, here we can see that applications of queue. Applications of queue. Here we can see DQ can be used both stack and queue. It support operation. DQ can be used palindrome checker. Next, here we can perform operations performed on queue. What are the different types of operations performed on queue? NQ, DQ, peak, queue overflow and queue underflow. NQ is nothing but adding the elements to the queue is going to calling as what? NQ. DQ, deleting the elements from the queue. Here we can see that peak. This is the third operation which is pointed to the front pointer of the queue. Next, queue overflow. It shows that overflow conditions when the queue is completely full. Next, underflow. It shows the underflow conditions when the queue is empty. When the queue is empty, no elements are there in the queue. No elements are there in the queue. This is what operations performed on queue. Okay. These are the operations we are going to performing on queue. Next, applications of queue. Due to this, we are going to perform some applications. This is what first application, first in, first out principle. They are having various applications. First, we are going to see that waiting list. Where we are going to see the waiting list? For example, there will be what in a room there will be one printer. If I am doing the multiple systems we are using, multiple systems are connected with the printer. Then the person those are going to get the first print, he only has been going to get the what? He only has been going to get the print. Here we can see that queues are widely used. Waiting list for a what? Single shared resources like printer, disk, CPU. Next, Queues are used in what? Asynchronous transfer of data. Not being transferred at the same rate to process. For a example, pipes, files, IO sockets. Queues are used buffers in the most applications like MP3, media player, CD player, etc. This example we know that very well. Where we are going to see this one, sir? We are going to see this one in the, if you are having the mobile. In a mobile, I want to play the songs. First thing what happen if I am going to open the Spotify or else Wink Music, whatever it may be. Automatically, when I am going to searching the song for of the favorite hero or else what any of that one. What happened in a movie? There will be 6 songs. First, I am going to play the first song. Then automatically, what happened if the completion of the first song automatically is going for second song. Automatically, actually will go for third song, like fourth song, like fifth song. Like that, it is also queues are used buffer in the most of the applications like MP3 media players, CD players, etc. Queues are used to maintain the playlist in the media players in order to add or remove the songs from the playlist. In the in my mobile, they are having what multiple songs. So that I want to make it, I want to place those songs only. So that at the time, what I will do, some songs I will be removing from the what list. Queues are used in operating system for handling the interrupts. These are the what, sir? Applications of queue. Applications of queue. Let us see one video about the queues. Queues in C. Queues in C. Let us see. Queue is basically a linear data structure that stores and manipulate the elements in the data flow. Manipulate the elements in the data flow in order to what? First in, first out principle, or else last in, last out principle. Next, here we can see that. Here we can see that queues are implemented using linked list arrays. We will be going with the what? Arrays also. Next. Two main functions. What are the two main functions? NQ and DQ. NQ stands for adding the elements to the queue. DQ stands for deleting the elements from the queue. Next, it functions manage to any of the errors. Let is empty, is null, is empty. It has been going to check whether the queue is empty or not. Is full. It has been going to check whether the queue is full or not. Peak is nothing but getting the value from the front of the queue. Next, here we can see that working of queue. Here we are going to working the queue with the what? Some what? Front. And next one will be what? Rear. Front will be what? Front side. Rear will be what? Back side. In the back side, I am going to inserting the element deleting from the what? First. Here we can see that empty queue. When I am going to see that this will be what? My empty queue. This will be what? Adding the element into the queue. After that, what I am doing when it is at 0, so that what happened? It moves to what? Here. Then afterwards, automatically it has been going to be deleted. Deleted means it has been going to comes for what? -1. This is about working of queue. Working of queue. Next, here we can see that these are the what? Front and rear. These are the what? Front and rear. First, there is a queue is an empty. Second, what happened? There will be what? Inserted one element. Next, second element. Next year 3 elements. Next year 4 elements. Next year 5 elements. At last, what? There will be what? Only one element. That one element is also has been going to be containing automatically deleting one by one. Queue is empty. Element 1 inserted. Element 2 insert. 2 elements are inserted. Here 5 elements are inserted. Here automatically the elements are deleted. At last there will be what? Only one element. That is 5. DQs. Deleting from the queue. Okay, that's all. Thank you.